Okay, we were looking last lesson at tangents and circles and how they linked in. So the example we're going to start with today is going to be, and I'm sorry the questions are a bit lengthy, but here we go. Find the length of the tangents from the point 5, 7 to the circle x squared plus y squared minus 4x minus 6y plus 9 equals 0. Can anybody suggest what it would be good to do to start with, the way we started last time? James?
Would you like to rearrange the circle equations?
Yeah.
But yes, it was.
Yeah, okay. Have your x squareds, then your other x bit. Then what do we do next at this point? Yeah, leave a gap, okay? Then go for your y squared, your minus 6y. I might as well move that 9 at this point, leave a gap and move that 9. Right. Can anybody then take me through, unless you want to carry on, James?
I was going to say that you but it's like completing the square.
Like completing the square? Yeah.
It's x minus 2.
Yeah, that's right. We look at what half of that is. Half of that is minus 2. So we will have x minus 2 all squared. But if you multiply that out, what will we have that we don't want?
Would you have minus 4?
Well, we would have a plus 4.
Plus 4.
So what we need to do is to put a minus 4 in to get rid of it. That would come from the minus 2 times the minus 2 would be a plus 4. We need to get rid of it straight away. So over here, we're going to do the same thing here. Half of that minus 6 is minus 3. So that's what will be in the bracket there. What will I have? What will just appear in here now that I don't want? A 9, yeah, from the minus 3 squared. So we'll take that 9 off straight away, and I've got the minus 9 over there. So, once we get to this stage, what was the next thing we did? Patrick?
You basically just rearrange it so it's x minus 2 squared plus y minus 3 squared equals plus 4.
Yeah, I moved these number bits over the other side. So that minus 9 stays there. A plus 4 and a plus 9 appear over here. So as Patrick said, that's just 4. What may be even a more useful way of writing, though, that 4? Anybody? Someone just said it. 2 squared, yeah. So, if we've got the circle like that, what do we now know about this circle? Yeah. Yeah, centre is 2, 3, and the radius is 2. Okay, so that's a bit of key information probably for this question. Now we had to find the lengths of the tangents from the point 5, 7 to the circle. What I suggest you do now is a little sketch. And because these sketches can go wrong quite easily, what I start with often is my circle. Okay? Then I worry about where the axes and things are going to go. I know the centre of my circle is at 2, 3, and I know the radius is 2. What do I know? Sorry, that's gone out of focus. If that happens, please tell me. What do I know then about the axes in relation to that? I know the radius is 2, and that centre is at 2, 3. Will it touch? Will it cross? Will it not reach? Go on over here.
It's going to touch the y-axis at one point.
Going to touch the y-axis, yeah. Okay, because the y-axis is 2 units away, so it will touch the y-axis. Will it touch the x-axis?
Across the x-axis. Like, no, it won't touch.
Yeah. The centre is 3 units above the y-axis. That's where the 3 there is. But it only goes down 2, the radius. So it's going to be like that. Okay? where that is going to be the point 2, 0, and that is going to be the point there, 0, 3. So we've got our axes. And it mentioned in the question the point 5, 7. How far over does this circle extend? What's the right-hand-most value here? Go on, Callum.
4, 3.
Wait, 4, yeah. What's the highest point of the circle? 5, yeah, because it goes up 2 from that 3. And we're interested in the point 5, 7. 5, 7 is further to the right and higher up than that circle goes. So I'll stick this point over here, 5, 7. It's not meant to be to scale, but at least you've got it touching the axis, not crossing it, whatever. That is working correctly. And it's talking then about the tangents plural from that point to the circle. That is going to be a line from here. Now, I'm not sure if I've got a ruler to hand. Let's use this bit of paper. See if this works. It's going to be 1 there, like that, and then 1 here, like that. Those will be the 2 tangents, okay, from that point to the circle. Now, what other lines could I draw on here? And what maybe two different circle theorems from GCSE come into play here? I'm going to give some other people a bit of thinking time as well. 2 circle theorems from GCSE and some other lines that might be useful to draw. Go on. Yes, that's right, okay. The point from here to the tangency point, so that distance there and this distance here, so that distance and that distance are equal. That's from a circle theorem from GCSE. Anybody got anything else then? Go on.
Could we draw in the normals to the centre?
The normals to the centre. What's another word we could use for that? You're right.
Perpendicular.
And what will they be? You're still right.
The radius.
The radius, yeah. The normals will be the radius. Again, for your other circle theorem is, now the tangent and the radius are at right angles. So yeah, they are normals. Okay, you were quite right. But the normal here is the radius. So we get that. Now, going back, the question was asking us the length of the tangents from the point 5,7 to the circle. So we're looking for this length down here. Okay. Here's that felt tip pen. Right, so just to make it really stand out, we are after that length there. Okay. So, can anybody suggest anything we could do? Callum?
Could you make that into a right angle triangle
By
by putting the centre point, drawing a line from the centre point to the 5, 7?
yes, you can. What we've got then now is 2 right-angled triangles. The top right-angled triangle here and a bottom right-angled triangle there. And what I suggest we do, now we've got that, is just do a sketch of the top right-angled triangle, which looks something like that. So that was the point 2, 3. This was the point 5, 7. That is what we are trying to find out. So, can anybody suggest a way forward from here? Go on.
Would it be to find out what the point on the last point? Oh wait, no. No, no way.
Okay. We can go to somebody else. Yeah?
I've gone, you've worked the gradient, so you've gone along 3 and up 4.
If I go here like this, we're saying I have gone from 2 across to 5 across. So I've gone along 3. And I've gone up from a height of 3 to a height of 7. So I've gone up 4. I want to find this length here. What am I going to use? Pythagoras Theorem. Yeah. Okay. 3 squared plus 4 squared. Square root that. I'm finding the hypotenuse, the longest side. That's what I'm adding. What will that give me? 5. Okay. So 5 is the length of that line there. Have we done that correct? Yes, we have done that correct. Okay, is that correct? Okay. 3 squared plus 4 squared, so 9 plus 16, 25, square root of that, 5. Okay. Are we okay with that one? Right, okay, I'm going to stop the video at that point.